It wants us to decide whether the function f of x, which is equal to x to the fourth minus 7x squared plus 6x, has any local maximum or local minimums. Find each max and min value of x which the minimum and maximums occur. So we could do this on a calculator. Only thing I'm going to do is plug in the function. So I'm going to say whoops, got to go to my thing here. X raised to the fourth minus 7x squared plus 6x plus 6x. Alright, so now when I graph it, now I'm going to zoom out a little bit. They actually graphed it in the book, but that's okay. I want to graph. Oh, I didn't turn on the thing? Oh, I'm sorry. How about... How long were you guys going to let me go like that? All class? Then you're gonna go home and say, Mr. Adams, I couldn't do the homework because you didn't have the screen on, and that's why I couldn't see. Oh, what's going on? Let's change this to negative 15 here. Alright, Mr. Adams couldn't see the graph. Oh, dang it, I still can't see it. Do you guys see what I'm doing here? I'm trying to zoom out in the y direction to fit all those valleys and humps. So the minimum and maximums, we're used to seeing absolute minimums and absolute maximums, right? But what we're talking about here are local minimum and maximums, and basically they're hills and valleys. So when you look at a graph, wherever you see a valley like this down here, or wherever you see a hill here or a valley here, it's a minimum or maximum. And to calculate which x value gives you the minimum or maximum, you can simply do on the graphing calculator. Later on I'll show you guys how to do this algebraically. But what I want to do is I just want to go to my first minimum here and go a little bit to the left of it, go a little bit to the right of it, and then try to guess where it is, which is about right there. And so when x equals negative 2.05, I get a minimum value of negative 24. So on that little hump, and then when we look in the textbook, it's kind of hard to see, but they've rounded it to 2.6. Right? That was their solution. So we're doing good so far. So now this point right here, where the cursor's pointing, is that a minimum or a maximum? That's a maximum. So what I'm going to do is I'm going to hit second trace. I'm going to choose maximum. Now, when it says, see this how it says lower bound right here? That means that I got to go a little bit to the left of the top of the hill. So that looks good. Then it says right bound. I'm going to go a little bit to the right. Then it says guess. I want to try to get right in the middle, on top of the hill if I can. So the next one occurs at 0.455. Okay. 0.55, and it looks like here in the textbooks here, right here, they labeled that as, let me highlight these so you guys can see these. So we found this value here, right, and then this is the other value here is the 0.46, and so we've got one more to go. This value here, is that a minimum or a maximum right here? Minimum. Second calc. Now, one thing I want to point out, it's a fourth degree polynomial. How many mins and maxes total do we have? 3, one less. So if I gave you an 8th degree polynomial, how many mins and max might you expect? 7. 7. Now sometimes you'll have less, but you'll never have 8. Does that make sense? Alright, so what did we say that was, a minimum? So another minimum, left bound, a little bit to the left of the minimum value, a little bit to the right of the minimum value, and then we guess. And that's 1.6, and guess what? The textbook says there's a 1.6. Any questions on that? That is example